In this video, we will introduce writing the RMI server within the Java programming language. RMI applications can comprise two separate programs, a server and a client. A typical server program creates some remote objects, makes references to these objects accessible, and waits for clients to invoke methods on these objects. A typical client program obtains a remote reference to one or more remote objects on a server and then invokes methods on them. RMI provides the mechanism by which the server and the client communicate and pass information back and forth. Such an application is sometimes referred to as a distributed object application. Our first step to implement our remote server is to define our remote interface. By extending the interface java.remote, the user service interface identifies itself as an interface whose methods can be invoked from another Java virtual machine. Any object that implements this interface can be a remote object. Taking a look at our code here, we can see that we have interface user service. To create our remote object, first define an interface that extends the java.rmi remote interface, just like we do here. The remote interface is a marker interface that does not have any methods of its own. Its sole purpose is to tag the remote objects so that they can be identified as such. One definition of a remote object is an instance of a class that implements the remote interface, or any interface that extends remote. Your subinterface of remote determines which methods of the remote object clients may call. In this case, this would be the user service interface. A remote object may have many public methods, but only those declared in a remote interface can be invoked remotely. The other public methods may be invoked only from within the virtual machine where the object lives. Each method in the subinterface must declare that it throws remote exception. Here we have two methods, and both of them are going to be called remotely. Both of them throw remote exceptions. Remote exception is a superclass for most of the exceptions that can be thrown when RMI is used. Many of these are related to the behavior of external systems and networks and are thus beyond your control. We here declare two methods. Our first method is say hello, and it takes no arguments and returns a string. Our second method, findUser, takes an int as an argument, proceeds to find a user, and returns a user object. An RMI server program needs to create the initial remote objects and export them to the RMI runtime, which makes them available to receiving incoming remote invocations. Now let's implement our actual server object. Declaring the remote interface being implemented, which in our case is a user service. Here we create the remote object that provides the service. In the following line, we export it to the Java RMI runtime so that it may receive incoming remote calls. The static method unicast remote object exports the supplied remote object to receive incoming remote method invocations on an anonymous TCP port and returns a stub for the remote object to pass to clients. As a result of the export object call, the runtime may begin to listen on a new server socket or may use a shared server socket to accept incoming remote calls for the remote object. For a caller or client to be able to invoke a method on a remote object, the caller must first obtain a stub for the remote object. A Java RMI registry is a simplified name service that allows clients to get a reference or a stub to a remote object. A registry is used only to locate the first remote object a client needs to use. Once a remote object is registered on the server, callers can look up the object by name, obtain a remote object reference, and then invoke remote methods on the object. The static method locateRegistry.getRegistry that takes no arguments returns a stub that implements the remote interface, the java.rmi.registry.registry, and sends invocations to the registry on the server's local host on the default registry port of 1099. The bind method here is then invoked on the registry stub in order to bind the remote object stub to the name hello or user servers or whatever name that you give your remote object. This name here is the actual name that our client will be looking up, whereas in this is the stub. We're going to be printing out a server ready message to the console, and we're also catching any exceptions. Now let's look at our actual methods that are being implemented. Our say hello method simply returns a string with the contents of hello world. Our find user method creates a map of users. With the ID provided, it gets the user and returns an instance of that user over the wire to the client. And here we see that the ID provided is actually returned from our map. This concludes our discussion of writing the server in Java.